Okay, so for number 22, we're given this graph, and it says write in terms of first sine, then cosine in the form a equals sine of b x minus h plus k, or y equals a cosine of x minus h plus k. So first we're going to do sine. So something I always like to know is normally sine starts at zero, like in the middle of it, right? So if this is my graph for sine, it starts something like that. Cosine, on the other hand, starts at the top. So I'm gonna look here and I'm gonna say at zero, are we at like the top or like the bottom of a wave, or are we in the middle of one? In this case, we're at the bottom of a wave. So that means that normally I'd want to use cosine, so I'm gonna have to shift sine in order for it to match cosine. And if this were like a cosine, which is gonna be part B, we're not gonna have to shift it, but for this one, we are gonna have an H. So I just wanted to kind of note that. Okay, so we're gonna have something in the form of a sine of b x minus h plus k. Our a is our amplitude. That's how far up or below the middle we're going. Well, if our highest point is 5 and our lowest point is -1, that means our middle is halfway in between, and halfway between 5 and 1 is 2. So our amplitude is going to be the distance from the middle to the top or the bottom, which is 3. So we're going to have a 3 sine. Now, I'll touch on the middle in a little bit. But for our k, normally our midline, or like the middle of our function, halfway up, is at 0. So if we're going from 0 and now it's at 2, that means our k is 2. Okay. So now our b. Now something important to know about the b value is b is 2 pi over your period. Your period is how long it takes for it to repeat. So one way I can look at this is at the bottom of the curve at 0, and it's also at the bottom of the curve at 2 pi, or 20 pi, sorry. The time in between, which is 20 pi, is our period, right? If I want another 20 pi, boom, I'm at the bottom of the curve again. So every 20 pi, our little wave repeats. So it means our b value is going to be 2 pi over 20 pi. The pi's cancel. 2 over 20 is assuming it's 1 over 10. X minus. And now to figure out what our h is going to be, I'm going to use the fact that sine of x minus pi over 2 is the same thing as cosine. So I said earlier, this thing kind of starts like a cosine. So that means that to write in terms of sine, right, aka to make the sine start at our minimum, we have to subtract pi over 2 from it. But here's the thing. We also need to factor out a 1 over 10. So that means to figure out what goes in here, I'm going to take our pi over 2, I'm going to divide it by 1 over 10. So whenever I do that, what I'm going to get is I'm going to divide the fractions, so I'll keep the first one the same, change the middle thing to a multiplication, this division, and I'm going to flip the bottom one over to be 10 over 1, and I will get 5 pi. So that means I'll have x minus 5 pi in the middle. So I got to write the function over here, I got y equals 3 being my amplitude, sine, and then, because I'm told this one has to be sine, on here we have 1 over 10, because we get that from our period, x minus 5 pi. One way we can think about this is if I distribute the 1 over 10, I'll get something times x minus pi over 2, which that's how you shift a sign from starting in the middle of your wave, sorry, versus starting at the top or the bottom, which in this case is the bottom of the wave. And lastly, our midline got moved up, so it's going to be a +2. Now I'm going to go to the left side to do the next one. In terms of cosine, well, I just mentioned, because we're starting at the bottom of the wave, we don't need to shift our cosine at all. So that means we're going to be in the form y equals a cosine of bx plus k. Our period is going to be the same. So that means our b is going to be 2 pi over our period. And that is going to be 2 pi over 20 pi, which again is 1 over 10. So I'll start to write it. And what else is going to be the same? Well, our midline is also going to stay the same. Now, for this a value, because we're starting at the minimum, that means our amplitude has to be negative for cosine. So that means that instead of 3, we're going to put a -3. Because if we plug in 0, cosine of 0 equals 1, but we want to start at -1, so we need 1 times -3 plus 2 is -1. If this was a +3, then we would have started at the top, which would have been the 5. So to put in our answer, we get -3 cosine of 1 over 10x plus 2. So for this next one, you find a possible formula for a trigonometric function with a minimum value of 0 and a maximum at 3 pi over 8, comma 5. We need to write our answer either in the form of a sine of bx plus k or a cosine of bx plus k. So I'm going to go ahead, I mentioned it last time. In order to figure out if you have sine or cosine, you say, do we start in the middle or do we start at a minimum or maximum? So we start at a minimum or a maximum, then we use a cosine. In this case, we start at the minimum. So we're going to be in the form a cosine bx plus k. And specifically, if you start at the minimum, that means that this a value, whatever it is, we need to make sure that's a negative. So from there, we can go about and try and figure out stuff. So our minimum, so let's go ahead and let's figure out what our a value is. Well, from the minimum to the maximum, that is a difference of 5. So halfway is 2.5, right? And that's actually what our midline is going to be. So I can go and put that in. And so the distance between our midline and our either max or min is going to be our amplitude. In this case, either way you go, it's 2.5. So it's going to be -2.5 cosine of bx plus 2.5. Now, another thing we can use is that because we start at the minimum, this max and this max are basically equal distance on each side. So this is going to be -3 pi over 8, comma 5. And that's 3 pi over 8, 5 as well. And our amplitude, in our period, looking for a b, which is 2 pi over our period. Well, our period is how long it takes for something to repeat. So that means that if we can find how far apart 3 pi over 8 is from -3 pi over 8 is, whatever that is, that is our period, and we can find out what our b is. So to figure that out, I'll do 3 pi over 8, and I'll subtract -3 pi over 8, which is going to become 3 pi over 8 plus 3 pi over 8, which will get me 6 pi over 8, which I can reduce to 3 pi over 4. So That means my b value is going to be 2 pi, and I'll put a little divided by 1, because that's the same thing as 2 pi, over 3 pi over 4. So when I divide fractions, we keep the top one the same, we change it to multiplication, and we flip the bottom one over. So the pi's cancel. 2 times 4 is 8. 1 times 3 is 3. So that means our b value is going to be 8 over 3. So go ahead and put this in our equation in. Y equals negative 2.5. Cosine of 8 over 3 x plus 2.5. Okay, so going into this next one, we are given that one summer day, the high temperature was 103 degrees Fahrenheit and the low was 69 degrees. The temperature throughout the day can be modeled by a sine or cosine graph where t represents the hours after 3 a.m. Find each of the following. Is this graph modeled by a sine or cosine function? Well, like the previous ones, we can just, if it starts in the middle, I'll write this down because I'm saying it so much. Not like that. Put it in blue. If it's in the middle, that's sine. So I'll say starts middle. If it starts at the maximum or the min, that is cosine. Specifically, that for that one, A is positive. For this one, A is negative. So in this one, do we start at a maximum or minimum? This one we start at a minimum, so this would be a cosine function. So horizontal left-right shift. Well, if our answers are in the form of this, because at the bottom it says write our answers in the form of that, notice that horizontal shift, that would be an x minus h, a b times x minus h. Because we don't have one, we already know it's going to be 0. Okay, our amplitude, one way we can find it if we're not given what our midline is we can take our minimum, which is 69 degrees, our maximum is 103. If we can find the difference between those, halfway in between that will be our midline, and the distance between our midline and either our min or our max is going to be ours. So to figure out what's halfway in between 69 and 103, we can just add them together and divide by 2. So we get 172 over 2, which is 86. So 86 degrees is halfway in between. My best approximation of where that is. So the question is, what's the difference between 103 and 86 or 86 and 69? Well, either way, that difference is 103 minus 86 is 17. 86 minus 69 is also 17. So our amplitude value is 17, but our value of A, remember, because we're starting at a minimum, A needs to be negative, is going to be negative 17. So while our amplitude is positive, our A value, we need it to be negative. What is our period? Well, our period is how long will it take to repeat. Well, we can see that we have a minimum at 0. We also have a minimum at 24, which makes sense over the course of a day. So what was our period? It is 24 hours. Well, what is our B value? Well, B is 2 pi divided by our period. So 2 pi divided by 24 is, we can make that 12. It's just pi over 12. Over 12. Our midline is y equals, we found that was 86. And our value of k is also just going to be 86. That one's going to be pretty straightforward. So our equation is going to be minus 17 cosine of pi over 12 x plus 86.
Okay, so it says a company's sales are seasonal with a peak in mid-December at t equals 0 and the lowest sales in mid-June at t equals 6. So let's label some of these things on our graph. So there's my trigonometric function, represents the sales in thousands of dollars at time t. What are the highest and lowest sale amounts? So one thing I want to take a look at is where my midline is. So I know my midline is at 68.7, so I can put that in here. So then we also want to consider the amplitude. So I know the amplitude is 43.2. So what that means is it's going to go up by 43.2 and down by 43.2. And so what I can do is just add those two together. So if I do 68.7 plus 43.2, I'm going to get 111.9 for the maximum. And for the minimum, I'm going to do 68.7 minus 43.2, and I get 25.5. So the highest sales is 111.9, and the lowest sales is 25.5. Okay, for the next one, it says determine the amplitude, period, phase shift, or vertical shift of the graph. So the amplitude is going to be 3. So usually we take the absolute value of that number there. The period is going to be 2 pi over b, because 2 pi is the normal period of cosine divided by b, which is 4, so it's going to be pi over 2. So the period is pi over 2. The phase shift is going to be this value here, so we're going to go pi over 8 to the right. And then the vertical shift is given by this number here, and so it's up 1. Find the amplitude, period, and phase shift of this one here. So it's going to be similar. So the amplitude is 5. The period, well, this one is not quite the same because I don't have it factored out. So this is going to be equal to 5 sine, and I want to factor out the 2. So I'll have 2 over x minus, and when I do pi over 4 divided by 2, I'll get pi over 8. So my period is going to be 2 pi over 2, which is going to just be pi. And for the phase shift, I can see it's going to be right here. So it's going to be pi over 8 to the right. And it's just a coincidence that they both ended up being pi over 8. Okay, so if I look at this one, find the equation of the line that intersects the x-axis at that point. So one thing we want to know about is that the tangent of this angle will be the slope of this line. And why is that? Because the tangent is y over x, or it's the change in y over change in x. So the tangent of that angle is going to give us the slope. So the slope, m, is equal to tangent of pi over 3. And then it has to pass through the point 5, 6. Okay, and so we're going to use our point slope form. So I'll do y minus y1 is equal to m times x minus x1. And so the x1, y1 is the 5/6. x1, y1 is the 5 and 6. Okay, and so if I want to find tangent of pi over 3, again, I can go back to my unit circle. And remember, at pi over 3, we'll have 1/2 for the x and root 3 over 2 for the y. And so it's going to be root 3 over 2 over 1/2, which is going to give us just root 3. Okay, and so it's going to be y minus 6 equals root 3 times x minus 5. And so that is our equation. It says give exact values, then round to 2 decimals. So if you want to round that square root of 3 to 2 decimals, that'll give you the other answer. All right, this says given the tangent function that passes through 0, 0 and pi over 8, 6 with asymptotes shown, first describe in words how this is related to tangent, then find a possible formula. So I think that is not totally on the page. How about that? Okay, that looks better. So if I want to describe in words So the first thing I would notice is that there's a vertical stretch by 6. By a factor of 6. And then there's a horizontal compression by a factor of, well, see, usually the tangent function has an asymptote at pi over 2, and it goes through the point pi over 4, 1. So it goes through those points like that, right? And so it's smushed in by an additional 1/2. So there's a horizontal compression by a factor of 1/2. And yeah, so it should be 6 tangent, and then there's no vertical shift. So it should be 6 tangent, and then so another way to think about it is that the period is now pi over 2, but the usual period for tangent is pi. So the period is equal to pi over 2, but the usual period is pi, so it's going to be pi over b is equal to pi over 2, which means b equals 2. So it'll be 2x, and then plus k is 0. Okay. Then it says a transformed tangent function has vertical asymptotes at every odd integer and passes through the points 0, 1, and 0.5, -3. Find a possible formula. Okay, so one thing I might think about is that this one has been inverted, right? So the midline is like right there. And so it's been inverted by, let's see, so it's going to be a negative, and then the between 1 and -1.5, that is a 2.5. So A is going to be -2.5 tangent, and then the B is going to, we know that pi over B is equal to the period. Well, the period here is actually 2. So from -1 to 1, so that's 2. And so I can solve that for B. So I have pi equals 2b, and then I can divide, and I get b equals pi over 2. Okay, so tangent of pi over 2, and then plus, and then it shifted up 1, so plus 1. So that's the answer there. The next one, find the period for each of the following functions. Okay, so the period for tangent is usually pi. So the period is going to be pi over b. And b in this case is 1/8. So pi over 1/8, which is going to give us 8 pi. So the period equals 8 pi. For cosecant, the normal period for cosecant is 2 pi. So the period will be 2 pi over b, which is 2 pi over 2/3, which is equal to 3 pi. So the period here is 3 pi. The next one says, name any two of the vertical asymptotes for that graph in the interval from 0 to 10 pi. Okay, so let's think about what's happening here. So if b is pi over 6, then the period is equal to pi over 6, which is equal to just 6. Okay, and so what that means is that I'm going to have asymptotes on either side of 0. I'm going to go to the right 3 and to the left 3. So I have asymptotes there. And then I'll have an asymptote again, 3, 4, 5. So 3 plus 6 is 9. So I'll have an asymptote there. Okay, and so so I think x equal 3 and x equal 9 are two of the vertical asymptotes I can list. Now I want to see, are they in the interval from 0 to 10 pi? Now remember, pi is about 3.14, so 10 pi is like 30-ish. And so 3 and 9 are definitely in that interval. So x equal 3 and x equal 9. If I wanted to complete the graph of this, I can see I also have a stretch by a factor of 4. So it's going to go through 1.54. It's going to look like this. Okay, so the last one, it says name two vertical asymptotes at the graph y equals -5 secant of pi over 6x. So again, secant is 1 over cosine. And then my shift here is b is pi over 6. So my period is going to be equal to 2 pi over 6, which is going to be equal to 12. Okay, and so when I plot this out, I'm going to graph cosine. It's going to be a negative cosine, and my period is 12, so I'll do 6. Okay, and then cosine is going to be flipped over, so it's going to start here at -5, and then it's going to cross through at 3, and then it's going to hit its maximum of 5 there at 6, and then it's going to cross through again at 9, and then it's going to hit its minimum of -5 there at 12. So it's going to be doing this. Okay. And so that's, I should have made that dotted. Anyway, the graph of secant is going to be the flip of that. And so I'm going to have an asymptote here when it's equal to 0 and 9. So I'll have an asymptote at x equal 3 and at x equal 9. And then the graph of secant is going to look like this. Okay. So that's one period of the graph of secant. So there are two vertical asymptotes. Okay. The next says simplify the expression. Remember to show your steps in clear order. Okay, so let's think about changing everything in terms of sine and cosine is probably a nice way to go. So tangent theta is equal to sine theta over cosine theta. And cosecant theta is 1 over sine theta. And so that becomes 1 over cosine theta, which is equal to secant theta. Okay. For this one, I have cosine plus sine, the quantity squared. So if I square that out, I'm going to have cosine squared x plus 2 sine x cosine x plus sine squared x. And then I have minus 2 cosine x sine x. And the reason it multiplied out that way is, remember, I need to take this cosine x plus sine x times cosine x plus sine x. And when I multiply that all out, that's what I'll end up getting. And so I can see that this term and this term are going to add to make 0. So this will just be left with cosine squared x plus sine squared x. And that's one of my Pythagorean identities. I know that's equal to 1. Right? So for the next one, again, we can remember that cotangent is cosine divided by sine. So I'm going to get 1. All right, so for this one, let's see, you might be tempted to multiply that out, but I'm not sure that that's going to get us anywhere very fast. Let's think about our Pythagorean identities. And if we remember, one of our Pythagorean identities is that sine squared x plus cosine squared x equals 1. So that means that 1 minus cosine squared x equals sine squared x. So this thing here is just sine squared x, right? And then what is that thing? 1 plus cotangent squared. And another one of our identities is that cotangent squared x plus 1 is equal to cosecant squared x. So this is cosecant squared x. And what is cosecant? It's 1 over sine squared. So I'll have sine squared times 1 over sine squared, so that's going to equal 1. Okay, for this one, show that secant of negative x minus cosine of negative x equals sine x times tangent x. Okay, so let's just start with the left-hand side. And so I have to remember some of the things that I know about sine and cosine. So I know the graph of sine looks like this, and the graph of cosine looks like this, right? And so we have that cosine of negative x equal cosine x. And sine of negative x is equal to negative sine x. So let's think about secant. Secant is 1 over cosine. So secant of negative x is equal to secant of x minus cosine of negative x is equal to cosine x. And then now I want to transform that. So secant of x minus cosine of x. So secant again is 1 over cosine x, right? Minus, and I can get a common denominator by multiplying this guy by cosine over cosine. And then that gives me 1 minus cosine x, cosine squared x, over cosine x, which is equal to sine squared x over cosine x, which is equal to sine x times sine x over cosine x, which is equal to sine x tangent x, which is where I was heading. Express tangent t in terms of sine t if we're in that quadrant. So let's think about what quadrant we're in. So we're in the quadrant between pi over 2 and pi, so we're in here in the second quadrant. Okay, so for this one, I know that tangent t is equal to sine t over cosine t. And I know that cosine of t squared is equal to 1 minus sine squared of t. So that means that cosine of t is equal to plus or minus square root of 1 minus sine t. If I'm in the second quadrant, that means that tangent is negative, right? So I'm going to choose to represent cosine in terms of sine by using the negative value on the square root. So I have sine t over negative square root of 1 minus sine squared t. And so that is the answer there. So I'm just changing that cosine into a, using this Pythagorean identity, but I want to choose the minus sign here because I know that tangent is negative in this quadrant.